Welcome back to another episode where we dive deep into one of the biggest mysteries of all. What is time? Is time an illusion, a fundamental part of the universe, or simply a tool we use to make sense of reality? And if time behaves in such strange ways, could we all be time travelers without even realizing it? Today we're going to explore the nature of time and its mysterious role in shaping our lives and the cosmos. Time governs our lives, marking the passage of events. We measure it in seconds, minutes, hours, and years. It seems straightforward. It's the thing that makes us age, causes change, and dictates the order of everything that happens. But is that really all time is? Just a way to track events? Or is there something much deeper going on here? Let's start with what we know. Time is relative. This groundbreaking idea was first proposed by Albert Einstein in his theory of relativity, and it changed everything. Before Einstein, we thought time was constant, a steady backdrop against which the events of the universe unfolded. But Einstein showed us that time is flexible. It can speed up or slow down depending on where you are and how fast you're moving. The faster you go, the slower time passes. And if you were somehow able to reach the speed of light, time would theoretically stop altogether. Imagine traveling through space in a spaceship near the speed of light. For you, only a few minutes might pass, but on Earth, decades or even centuries could have gone by. In a sense, you'd be a time traveler, moving through time at a different rate than everyone else. This concept, known as time dilation, means that time doesn't tick the same way for everyone. It bends, stretches, and shifts based on your speed and location in the universe. But what does that mean for us in our everyday lives? Could it be that in some way we're all experiencing time differently? Everything in the universe is in motion, from the tiniest particles to the largest galaxies. Take a microscopic particle inside your body, for example. It might be moving at an incredibly fast speed compared to a massive object like a planet. But does that mean the particle and the planet are experiencing time differently? On the smallest scales, particles seem to move incredibly fast. From our perspective, it looks like time is speeding up for them. But what if those particles experience time much more slowly? The reverse could be true for larger objects, like stars or galaxies. From our vantage point, they might seem to move slowly, but from a cosmic perspective, maybe time is speeding by. In fact, we don't even have to go that far to realize that we're already experiencing a form of time travel. Just look up at the night sky. When you see the light from distant stars, you're not seeing them as they are now. You're seeing them as they were thousands or even millions of years ago, because it takes that long for their light to reach us. Some of those stars might not even exist anymore, but we're still seeing them because the light is only just now arriving. In a way, that means we're already looking back through time whenever we gaze at the stars. It's a strange and humbling thought. We're constantly interacting with the past just by looking at the universe. And then there's space travel. Astronauts orbiting the Earth are actually time travelers too. Because they're moving faster than we are on the ground, time for them passes just a tiny bit slower. When they return from space, they've technically traveled fractions of a second into the future. It's not much, but it shows that time travel is real, even if it's on a very small scale. So if astronauts are time travelers, does that mean we too are traveling through time when we look at smaller things, like microscopic particles? Could it be that time unfolds differently at these smaller scales in ways we can't fully comprehend? We know that at the quantum level, particles behave in ways that seem to defy our traditional understanding of time. They jump between states in ways that are almost instantaneous, as if time doesn't even matter. Now, this begs the question, why does time exist? Or more provocatively, does time even exist at all? Time, as we perceive it, seems so fundamental to our existence. We live, we grow, we age, and eventually we die. But if we really break it down, what is time but a sequence of moments? We've divided it into units like seconds, milliseconds, hours, These precise divisions that help us organize our lives. But why? Why does it have to be seconds or milliseconds? Is there any fundamental rule in the universe that demands we experience time in such discrete, measurable blocks? It turns out these units of time are human inventions, convenient ways for us to make sense of the world around us. We measure the rotation of the Earth to create days, the movement of the sun to create years, and we break down those cycles into smaller units like hours, minutes, and seconds. But these divisions are arbitrary. Why seconds? Why not something else? Is there some deep underlying mathematics to this? Or is it just the way our brains evolved to cope with the passage of events? Interestingly, when we look at the mathematics of time, it's not always as straightforward as ticking seconds on a clock. In quantum mechanics, time behaves more like a fog, blurring, uncertain, not always flowing smoothly. Particles exist in superpositions where they seem to occupy multiple places or times at once. Time, at the smallest levels, starts to break down into something much stranger than we can imagine. And this raises another profound question. If we can measure and manipulate time in such precise ways, why can't time flow backward? The universe, as far as we know, has a built-in arrow of time, something physicists call the thermodynamic arrow. It's tied to entropy, the idea that everything in the universe tends to move toward disorder. Imagine a cup of coffee cooling down or a glass shattering on the floor. These processes only go in one direction, toward more chaos, not less. This is why, on a large scale, time only seems to move forward. We remember the past, not the future, because the universe is always getting more disordered. But why is that? Why must time have this one-way street quality to it? Some physicists argue that if the universe were different, perhaps time could flow backward. In fact, on very small scales in the quantum world, time symmetry exists. Certain processes can happen forwards and backwards. The laws of physics don't explicitly prohibit time travel backward. It's just that we, as macroscopic beings, seem to be stuck on this one-way conveyor belt of time. And here's where it gets even more mind-boggling. If time is just a dimension, like space, then why do we experience it differently? We can move freely through space, forward, backward, side to side, but time only flows in one direction for us. Could it be that time doesn't exist at all in the way we think? Maybe our brains are hardwired to perceive time as linear, when in fact all moments, past, present and future, exist simultaneously, but we can only experience them one after the other. This brings us to another profound question. When we pass away, where does time go? Does time continue after we cease to exist? Or is it merely an illusion created by our consciousness? If time is a construct of our perception, does it disappear when we do? It's a question philosophers and scientists have been grappling with for centuries. Some argue that time is a property of the universe independent of our existence, while others believe that without an observer to measure and experience time, it simply ceases to exist. So, could time be more like a tool? Something we invented to help us make sense of the universe rather than a fundamental feature of reality? And if that's the case, does it even matter if time exists or not? Perhaps the real mystery is how we experience it, how it shapes our reality, and why it seems to flow in the way that it does. So what is time? It's not something we can easily define, just something we experience, a force we feel every day that shapes our world, our universe, and maybe even our fate. Thanks for joining me on this mind-bending journey. Until next time, keep wondering, keep questioning, and who knows, maybe one day we'll truly unravel the nature of time itself.